Hi dear students, I welcome you again to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to go ahead with definite integral from the chapter integrals. So today's concept, today's class will be on definite integrals. Let I erase this. Let us have some more space. Now don't forget, already part 1 and part 2 are being uploaded on indefinite integrals. Okay, so now let us move on to the concept of this, what's actually happening. Okay, now here, where am I? Now coming to this topic, what actually we are doing, and this we can this topic we can say no, this topic we can think as application of integrals. Why do we need? Okay, so for this, let us try to understand geometrically what's happening. See here, let us suppose that I have got a curve, and that curve is this, whose equation is y is equal to f of x. Okay, and this is a continuous function, so f of x is continuous, and here we are going to restrict to a closed interval a comma b, nothing but up to where the graph is there, we are surely defining it. And let us suppose that it is starting from here, that is x is equal to a, and as you can see it is ending here. Let us extend the x-axis. This is x is equal to b. Now in between I've got, okay, I did use this color. Okay, now here I would like to talk about fundamental theorem of calculus. Okay, so in this regard of fundamental theorem of calculus, fundamental theorem of calculus. Now see, here I want to find the area, so I would like to introduce one term, area function. Nothing but a function which is talking about the or deciding about the area a of x. See, area is a. I use the word function, nothing but it's going to vary. So let us suppose that this part, this particular region is having this particular region which I am shading. I am only bothered about this, and I have given a variable x. It means what? Depending on our choice, no, the x will vary. Okay, it is between a and b. So now coming to this area function, we have first fundamental theorem of integral calculus. To be very specific, integral calculus. Now what this says, if y equal to f of x is a continuous function, which you can see from the graph, it is continuous function, then in closed interval a comma b, then we can say that the area function which is there here, if I take the derivative of that derivative and this curve, whatever is there, both will be same. Okay, that's the meaning. Nothing but antiderivative, whatever I'm going to get before that, this is the derivative of the antiderivative, no, the original function, that and the derivative of the area function, both will be same. Okay, this is about first integral theorem. Now coming to the second fundamental theorem of integral calculus. Now what this says is, let us suppose again f of x is continuous. For this two theorem to be applicable, the function should be what? Continuous. So if the statement says if y equal to f of x is continuous in the closed interval a comma b, then the integral of a to b f of x with respect to x will be capital F of this we call lower limit and this we call upper limit. Okay, so it is f of b minus f of a. This is going to be the value of integral, definite integral. Now here where capital F of x is antiderivative. We have spoken a lot in indefinite integral. So first you have to find antiderivative and then you are going to integrate, means apply the limit. And it's very clear that definite integral is nothing but finding the areas. That's what we have discussed here. Okay, so having understood this, let us try to understand this one still more better. See, whenever we are going to have integral a to b f of x with respect to x, we know f of x is integrand. This is not new thing for us. The function to be integrated is known as integrand. Then this dx stands for we want to integrate with respect to x. Correct now? Then this symbol stands for we have to find the integral symbol. It is that we want to find the integration. What is this a stand for? This we call lower limit. What we call lower limit. And coming to b, see this is present below, so we call lower limit. A b is present above, so we call upper limit. B is called upper limit. Yeah, surely there will be some doubt now. So when you are applying, where is the integral constant c? What happened for that? Let us have a discussion on the same. First, kindly make a note of this, and surely we are also going to think of finding this area also undoubted. Now, what I am trying to say here is the way it's given. Here, let us comment one more thing. This area which we want to know is given by integral a to x. Nothing but till here. Let us suppose x remains x only. Okay, a variable function, and I want to find the integral. Nothing but the area, and this is above x-axis. Nothing but area will be positive. And already in application of integrals, I have discussed the cases. What if area is above, what is above below, and what is above both above and below. You can surely go to the detailed concept I have discussed there. Okay, and usually definite integral can be explained two ways. One is finding the areas, other is as a sum of the limit. Okay, fine. So having this, we can go ahead with the problem. And this x is saying no, as and now I want to vary. Let us suppose I want area till here, then x is here. So that's what now we have given here x. Nothing but this area is going to vary depending on I want to vary x here, but my interval is fixed. A and b are fixed. Okay, and here always you should also understand when we are integrating with respect to x, this value lower limit and upper limit are both of x value. But when adding a, and here I have written here no, a and b, those are fixed value. But if I want to vary the area, then I have got here x, a variable. Fine. So with this we are ready for the some more concept and then some formulas, and we'll go one by one. Okay. Kindly make a note. And undoubtedly this is for all x in the closed interval a comma b. That is obviously understood, but anyway I have specified. Now let us move ahead. Okay, dear students, now let us try to understand some of the concepts here. I mean to say, in indefinite integral, whenever we have integrated, just see this carefully, note wise we will take. Coming to note number 1, indefinite integral of, when I say indefinite integral, both lower limit, upper limits are not given. At the beginning of indefinite integral, part 1, I have discussed about indefinite and definite integral, how to identify. There I said definite integral, surely we are going to discuss in detail, and just now we have discussed some of the, actually the concept, detailed concept. Now, integral of f of x, if small f of x antiderivative is capital F of x, then we can say that integral of this is capital F of x plus the integral constant c. Now, when I give the concept, you can see that this c was not given. Now, how come the c is not there? Okay, now let's see carefully. Here I just want to use this. If indefinite integral of f of x is capital F of x, then how are we going to evaluate definite integral? So from here, one thing is very clear, that if at all you are perfect with what? Indefinite integral, definite integral solving for some of the problems should not be difficult. Surely you are going to also go for properties. Okay, recording now. Yeah. Now, indefinite integral, if I just see it is f of x, so I will just write the same f of x, then plus c I will write wantedly here, and I have to apply the limit from where to where? A to b. As we discussed today, that this is actually x is equal to a to x is equal to b. So similarly here also, no, it is x is equal to a to x is equal to b. So I have to surely apply upper limit as well as lower limit. Now, but when you are applying, it is only for x, not other than x. So here you can see x is present here. So I am going to apply upper limit. We are trying to have a discussion why in definite integral constant c is not present. Present you have taken. Okay, just see carefully. Now upper limit is b. So wherever x is there, b. There is no x, so c will remain c, the integral constant. Okay, then minus. It is upper minus lower limit. So now minus. Now let us see here. Lower limit is a. So it is f of a. Don't forget the bracket. This is the mistake. Then this lower limit when you apply, negative of this, whatever the antiderivative we have got. So this then plus c. Again, it is only in place of x, so we should replace by a. There is no x here, so c retains as it is. Now simplify this, f of b, then plus c, minus replaces minus, f of a, minus replaces minus c. So surely plus c and minus c got cancelled. So it means we are actually applying, and that means when we are going for definite integral, plus c is always given, but ultimately both are getting what? Cancelled, due to which we are going to have only f of b minus f of a. This will be the definite integral a to b f of x with respect to x. Okay, fine. And one thing surely will be there, no, why you are subtracting? Why is that no after upper limit, why it is lower limit? If you just analyze again what we just discussed, the graph, now see carefully. See carefully here. Something that one graph I took here, then this is x is equal to a, then here is x is equal to b, and this curve is y equal to f of x, and I want to find this area, correct? Now see carefully, when I'm going to apply integral a to b f of x with respect to x, let us suppose the antiderivative of small f of x is capital F of x, and then I'm applying upper limit minus lower limit. Now why minus? See carefully. When I'm saying f of b, is it not f of b will be the covering the area from here till here, this area entire from here left to right, the area is covered. From where to where? From left to right, the area is covered. From left to right, when area is covered, but I want only this area, the black color, but I have covered the extra area here, which I don't want, and that area is bounded since a is here, x is equal to a. So from here to here is what? A. So I want to remove this area, which is extra. How to remove that? Minus. And that area is given by x is equal to a with the antiderivative, so f of a. So I hope it's clear why that we are going for subtraction, why not something like addition or multiplication or division. It's only subtraction. We are removing the extra area. I hope this point is clear. Next, one more thing I also want to talk is what will be, getting this as a second note, what will be definite integral of 0. Definite integral of 0. from the graph you should be very clear. When I say 0, f of x, there's nothing. You can have only one vertical line. For a line, no, area is not there. For if at all you want area, for example, circle or rectangle, we see, for example, rectangle, we want both the length and breadth. Until unless we don't have length and breadth, we cannot get the value. I hope all of you agree. Area we cannot get. So to find area, we should have both what length and breadth. To find the height, we want just the length or the breadth. So you want 2D. So as soon as I've got either length or breadth, there is no area. There is no area for 0. That is very clearly understood. But let us try to go in this manner and try to understand whether it is 0, and if it is 0, how mathematically. Area wise we understood that how it is 0. That whenever the integrand is, there is no boundary itself, there is no curve itself. Okay. Now see carefully. Let us suppose the integral, as we know, coming to indefinite integral of 0. What is integral of 0 with respect to x? It is c. So same thing, right? C. Now I have to apply the limit from where to where? A to b. And this limit is applied for x value. X is equal to a to x is equal to b. So wherever x is there, replaced by b, upper limit, then minus lower limit a. Do we have x here? No. Correct? So we don't have x. So c will remain c for upper limit, minus. What's the lower limit again? A. So again here, c will remain c. C minus c is what? 0. So integral a to b 0 with respect to x is 0. So remember this. Okay. So having understood this, now let us move on to the problems from the model question paper. Kindly make a note. Yes, dear students, now let us move on to one marker question from model paper. As we know, it is issued by KSEAB board, PU board. Okay, now for this academic year, means your academic year, we have to find the definite integral from 1 to root 3, 1 divided by 1 plus x square with respect to x, and the options are given. Now see carefully here. First, don't think about the limit. Come to indefinite integral. What is integration of 1 by 1 plus x square? It is tan inverse x. Now what to do? Apply the limit. 1 to root 3. So be careful. These are x values. Replace x by upper limit minus lower limit. So tan inverse of upper limit root 3 in place of x, root 3, minus lower limit is 1. This is tan inverse 1. Tan inverse of root 3. Now comes inverse trigonometric function. It is pi by 3. Tan inverse of 1 is pi by 4. There, ITF have discussed all this how to get. Okay. Now, LCM of 3 and 4 is 12. 12 by 3 will be 4. So 4 into pi minus 12 by 4 will be 3 pi. So answer is pi by 12. Pi by 12 is there in option D. Okay, I hope this is clear. Now let us move on to the next. I have to get the integration of this. Now here it will be by using the formulas of trigonometric function. So first the problem is done. Now moving on to this, recall we have got multiple angle formula which says that some multiplication will take. First I'll take multiple to be clear. Cos 2x is equal to cos square x minus sin square x. Whatever the angle is there, half of the angle. Now if I take cos x here, see this, whatever the angle is there, half of that. So half of 2x is x. Sorry, not x. Now what is half of x? X by 2. So now it should be cos square x by 2 minus sin square x by 2. So now you see this and what we have got here. Cos square x by 2 multiple is positive sign. Sin square x by 2 multiple sign is negative. But we have got reverse of that. Okay. Don't think of doing adjustment. You have to make sure it should come to this manner. So either I can multiply negative out here or I can take minus common here. If I take minus common here, then see what we are going to have. Minus into minus will be plus cos square x by 2. Then minus into plus is minus sine square x by 2 with respect to x. Now let us complete the integration. Now see carefully, minus 0 to pi as it is. This is present here. I'm writing right to left, so I'm getting cos x with respect to x. So minus integration of cos x is plus sine x. It's not minus sine x, it is plus sine x. Okay, so 0 to pi, apply the limit. So minus sine of upper limit is pi, so where x is there, pi, minus lower limit 0, so sine 0. What is sine pi? 0. What is sine 0? 0. Don't forget this result, that sine pi is 0 as well as sine 0 is also 0. So 0 minus 0, so the value is what? 0. Therefore option A is correct. Okay, I hope the things are clear. Okay, just for you to give one more insight, no, if you just see this part, no, just see this part, the graph of this, if I draw, no, what is actually happening? Sir, you said area, suddenly how come area is 0? Just see here, cos pi means cos value from 0 to pi. This is the graph of cos, this is pi, this is 0. So you see, cos, this is your y equal to, our y equal to cos is graph. Now you see, whatever area is there here, same area is there here, but this is negative y, is like below x-axis. So whatever the area we have got, same area is here, nothing but here the area is 2, here also, here it is minus 2. 2 plus minus of 2 will be 0, correct? No, so this area is how much? 2, and this will be minus 2. That's the reason 2 plus of minus 2 both will get cancelled. You'll get what? 0. That's why we got 0 here. So, but coming to definite integral, we are not going to bother about all this graph. Only if the question is what, find the area, that we have discussed already in application of integrals. Only then we are going to think about taking mod or being careful that I should not have anything below x-axis, due to which it may cancel. Okay. But for definite integral, we are least bothered. Just you have to evaluate the definite integral. We are only bothered about the values. We are not bothered about the sign of the areas. Okay. Kindly make a note. Okay, dear students, having completed 2 problems of 1 marker from model question paper, now let us move on to the next concept, method of substitution for definite integrals. Actually, in none of the model paper, we don't have any problem in this concept, but as you're aware that we need all the concept. So I'm just going ahead with 2 problems from NCERT 7.10 exercise, first and fifth question. But before that, on the 2 model papers which I have solved, this will be your assignment. This is 1 by quadratic, which we have also seen in indefinite integral. Only after integrating, you have to apply upper limit minus lower limit. Okay. Now let's move on here. Now, how to know that you have to apply method of substitution? Because question will be only evaluate. Very simple. As I said, in indefinite integral as well, the derivative, if I take any substitution, derivative should be there in the question. Now, for example, derivative of x square plus 1 is 2x. Yeah, x is there here. Sir, 2 is not there, not a problem. Constant always you can manipulate. And just see. So, method of substitution. And one more thing is, even you can go for linear by quadratic. Okay, but compared to that, this will be easier method, will be method of substitution. And even if you see the partial fraction method we discussed, this is what? 1 by, this is non-factorizable term, so I have to take type 3. But compared to that, you see how easy this will be. So put x square plus 1 is equal to t. I'm saying compared to that, this will be easy. Be careful, because the derivative of this is the numerator. Let us suppose the derivative of this is not the numerator, then we have to be going back to partial fraction, or it can be like that. I think, but I did one problem, no, 1 by 1 plus x square model paper. It was directly tan inverse x. Okay. So we should be, in short, what I'm trying to say, we should be aware of each and everything. Now let us differentiate this. If I differentiate this with respect to x, derivative of x square is 2x plus delta 1 is what? 0 is equal to derivative of t with respect to x is dt by dx. 2x plus 0 is 2x is equal to derivative of t with respect to x. See, we have x dx. So cross multiply this dx and 2 here. So we are going to have x into derivative, okay, dx I mean say is equal to half dt. This is not something new. Method of substitution till here we have it. Now be careful. As I have discussed at the beginning that whenever the limit is there, it is for the variable x. I mean to say, since it is with respect to x, here it will be x value, that is 0 to 1. Now, since I have got a new variable, see, when I am going to substitute, see what's going to happen. As for I will say, put equation number 2, 3. Okay, equation number 2, 3. I'll just leave a space in 1. Why I have left the space, you'll come to know. If I do so, my equation number 1 will be x dx. What is x dx? Half dt. So half here, then dt I will write it here. Then x dx. This one it is half dt. Then divided by x square plus t. X square plus t we have taken as, I mean to say x square plus 1 we have taken as t. So denominator is what? T. Now see carefully. For all we have substituted, the entire integrand and dx, all substitution done. But the problem is, now since I have got here what? With respect to t, I have to integrate this. So my limit should be for variable t. But this is the limit for the variable x. So there is a change of variable. I mean to say there is a change of limit. Since there is a change of variable, there should be a change of limit. Now how to get the new limit? Very simple. Where you have went for substitution, that step we are going to go ahead and change the and obtain the new limit. See this, when the lower limit x is equal to 0 in equation number 2, put here 0 square plus 1 is equal to t, or 0 square is 0, 0 plus 1 is 1, so 1 is equal to t. Next, this is done. Next, when the upper limit x is equal to 1 in equation number 2. Again, why 2? This is the step where we have did what? Substitution, change of variable we have taken from x to t. Now, that's the reason we are going to obtain the new limit in the step of substitution. Now, when x is equal to 1, put here 1 square plus 1 is equal to t. What is 1 square? 1. 1 plus 1, 2. So the value of t will be 2. So my new limit will be t is equal to, see, be careful now, when you are writing also important. For x is equal to 0, we got new limit to be 1. T is equal to, so in place of x equal to 0, t is equal to 1. Then for x is equal to, I repeat, for x equal to 0, we got t is equal to 1, correct? Now here. Now for x is equal to 1, the new limit is t is equal to 2. When x is equal to 1, t is equal to 2. Okay. Now let us think of integrating. Half out. Integration of 1 by t with respect to t. I have applied scalar rule. Now there is no need to specify that t should be written like this. I just wrote to make you understand why there is a change of limits. Why this is required. Here, since dx is there, the limit is for x variable. Now since it is dt, it is for variable t. Now integration of 1 by t same as 1 by x, which is log of mod t. Now we can apply the limit. Now since the limit for t, wherever t is replaced by upper limit minus lower limit. So half of upper limit log t, log of mod t minus log of mod. To have a difference, I write 1 in this way. What is log 1 value? Recall what is log 1? It is always 0. So very clearly this value is 0, and let us have a close bracket. Here is the open bracket, so here is a close bracket. Now remaining will be very simple, half as it is, then log mod of 2 is 2. Okay, half log 2 will be the value of this. Okay, now let us move on to the next problem. Again, this is from NCERT. There is no question asked, just for the completion. And now, why I left the space? Now this I will regard as equation number 4. So put 2, 3 and 4 in 1. Okay, just I showed the steps. Now see here, How to know it is method of substitution? See, you have got sin x by 1 plus cos square x. What is derivative of cos minus sin? So it's there in the numerator and the derivative is present. So I can go for method of substitution. So put what? Cos x is equal to t. Now if I differentiate this with respect to x, derivative of cos is minus sin x, okay, is equal to, let us go step by step, is equal to derivative of t with respect to x. Now we have sin x dx. So this negative I can cross multiply and this dx here. So I'll get sin x derivative here is equal to minus dt. Now I will regard this as equation number 1. This entire thing we can take as equation number 2, and this entire thing we can take as equation number 3. Now surely I have to go for change of limit also. Don't forget this, whatever the limit we have got, it is, since with respect to x is here, this is x is equal to 0 to x is equal to pi by 2. So now let us go one by one. So when x is equal to 0 in equation number 2, see carefully, I can write cos 0 in place of x, value is 0, is equal to t. What is cos 0? 1. T is equal to 1. T is equal to 1. Now this is for when x is equal to 0. Similarly, when x is equal to pi by 2 in equation number 2, then put here what is cos pi by 2? Cos pi by 2 is 0. So this entire thing I'll take as 4. Now what I can say, put equation number 2, 3 and 4 back in 1. 2, 3 and 4 in 1. Now what we are going to get, see carefully, integral when x is equal to 0, when x is equal to 0 we got t is equal to 1. When x is equal to pi by 2, when x is equal to pi by 2, as you can see here, we got t is equal to what? 0. T is equal to 0. Then sin x dx. What is sin x dx? Minus dt. Okay, minus dt. We have substituted even the numerator. Okay, let us write dt properly. Divided by 1 plus, okay, 1 plus, in place of cos, what do we have? T. So I wrote t. And then since we have a square, so square as it is. Some students will be having a doubt, sir, why you are not taking cos square as substitution? See carefully. If I take cos square x is equal to t, now differentiate this. Now to differentiate this, I have to apply composite derivative. So you can see derivative of cos square will be 2 times of cos. Then what is cos? It is minus sin x. Okay, is equal to dt by dx. Now see carefully. I have only sine. I don't have cosine. That's the reason I have not taken square. Okay, so this is wrong. Now let us proceed. Integration of 1 divided, this is 1 I can write here, 1 divided by 1 plus t square will be tan inverse t, and this negative as it is. This is 1 here, mind it. Apply the limit from where to where? 1 to 0. Let us recall what is integration of 1 divided by 1 plus x square. It is tan inverse x plus c. So now apply the limit, minus, upper limit is 0. So tan inverse of 0 minus tan inverse of lower limit. In place of t, lower limit is 1. Now start. What is tan inverse of 0? 0. What is tan inverse of 1? It is pi by 2. Let us write 1 by 1. Here it is. Okay, let us write the next line. Okay. So it is minus 0. Then minus, this will be what? Pi by 4. Pi by 4, not pi by 2, pi by 4. Then minus is what? Plus pi by 4 will be the value of this. I hope this is clear. Kindly make a note. Okay. Dear students, now time has come for properties of definite integrals, and these properties will make our job bit easier to evaluate definite integrals. Okay. Now in each model question paper, we have got a 6-marker question on properties of definite integral. But we have around 7 to 8 properties, but there, since in the model question paper, it is taken as 6-marker question, and in each model paper, it's only one property given. So we have only 3 properties in model question paper. So surely I will derive, because derivation is also going to carry a marks for 6 markers along with the sub problem. But the other properties I'll just list out. So let us first list out before we go ahead with that, so that you are aware which how many properties and what the property says. So coming to properties of definite integral. The first property P naught, I'll write it here. P naught, it says integral a to b f of x with respect to x is same as integral a to b f of t with respect to t. Now suddenly you'll be thinking, sir, just now you said if you change the variable you have to change the limit, but here you are not changing the limit. Property says it should be same. Try to understand. Here exactly in place of x we have got a t. It's a linear, and I'm saying linear, it is identity function or identical substitution. Just we have changed the variable from x to t. They are not did any extra thing like adding, means x is equal to t plus 1, x equal to t minus 1. We have not added any constant, just direct replacement. When we replace the variable, then there is no problem. Okay. Now, and you can see here, when x is equal to a, t is also a. When x is equal to b, t is also what? B only. Okay. Next property is P1. This says integral a to b f of x with respect to x is same as minus of b to a f of x with respect to x. And here in particular, what? Integral a to a f of x with respect to x is what? 0. Whenever lower limit, upper limits are same, the value will be what? 0. Nothing more, there's no area covered. There's a meaning there. And here, where, sir, you said area not covered. What's the meaning? See carefully. Coming to definite integral, we have got this curve, correct? No? Now you see carefully. When you said definite integral, the area is going from where to where? X is equal to a to b, we say, correct? No? When x is equal to a to b, this is the area. But when I say a to a, it means what? I'm here only. I think about a line. A line will not have an area. We want length and breadth. For example, rectangle case. We want a 2D, not 1D. For 1D, we'll have only length, not the area. That's what we can interpret. See how we can interpret the property with the geometry. That's what the understanding. That's the concept power. Okay. Yes, shortcuts are there, but concepts are not. Concept can't be ignored. Okay. Now, concept will never ditch you. Trick when you're applying, we have to be extra careful when to apply that trick. Okay. Now integral a to a f of x with respect to s is 0. Now one more property. Okay. It was about to fine. It didn't came. Next property. As I said, these are property not, it was not been given in model papers, but I'm stating. Next one more property we have got is integral a to b f of x with respect to x is integral a to c f of x with respect to x plus integral c to b f of x with respect to x. So we can break the integral at a point c. Okay, this property is been is there. Now let us move on to the problem which is asked in model question paper. Kindly make a note of this property. Okay, dear students, now let us move on to the properties. Now here, as you are aware, there are 2 6-marker. One is on linear programming problems and other is on definite integrals. Any one you have to answer. Okay. Now coming to this, a 6-marker question from part E, and again as usual from model question paper, and this has come in which model paper for a while? Okay, model question paper number 3. Fine. From again KSEAB board for the academic year 2025 2026. Now let's go ahead. We have to first prove the property and then we have to solve a problem on that. This will be a trend for all the 6 marker. Now just see, coming to the proof, no, they themselves have given you the hint. So coming to the question, left hand side, integral of a to b f of x with respect to x. I have taken the left hand side. Now you see yourself, see what we have to prove. In place of x, you see what is given here, a plus b minus x. So they themselves are saying that you have to substitute. I hope now you understood why I went for method of substitution, even though there were no problem on that. Okay, that's what concept cannot be ignored. So put in place of x, a plus b minus x. So a plus b. Now change the variable to some other. So why are you changing the variable? Let us suppose I write x here. Then what many will do? Transpose and simplify. Correct? No. That's the reason we have given a different variable. Okay. Now this is my equation number 1. Now I have got this variable here. No, x is equal to a to x is equal to b. First, now differentiate this with respect to x. Derivative of x is 1. A and b are constant, so derivative of a is 0 plus b is also a constant. Derivative of b is 0 minus derivative of t with respect to x is derivative of t dt by dx it is. Now if I cross multiply here, 1 into dx is dx is equal to 0 plus 0 minus dt will be minus dt. Fine. I hope clear. Let us highlight this. So here is the substitution. This will be regarded as equation number 2. This is dx is equal to minus dt. This will be regarded as equation number 3. Now change of limit should also happen. So now see carefully in this substitution when x is equal to a. So when x is equal to a in equation number 2, this implies a is equal to a plus b minus t. A and this a will get cancelled. We are going to have 0 is equal to b minus t. Transpose this. I can say t is equal to b. This is our new limit. When x is equal to a, we have got t is equal to b. Now next, when the upper limit is b, when x is equal to b, put in equation number 2. This implies, see carefully, equation number 2, x is equal to b. So b is equal to a plus b minus t. So very clear, you can see b by means b and b will get cancelled on either side. So now what is remaining? 0 is equal to a minus t transpose. So we are going to have t is equal to a. T is equal to a. I hope this is clear. Now let us proceed. See carefully. This we will regard as equation number 4. Now put equation number 2, 3 and 4 back in 1. Put equation number 2, 3 and 4 back in 1. So coming to this 1. Okay, equation number 1. When we want to substitute, let us highlight. Okay, this is our equation number 1. Correct now? Now when I'm saying put 2, 3 and 4 back in 1, 1 is here. So see, in equation number 1 we have integral. Find integral from where to where? A to b. Lower limit is a. For lower limit a, what is the new lower limit? B. So t is equal to b. For upper limit x equal to b, x equal to b, the new upper limit is t is equal to a. Next, f of, okay, f of, in place of this x we have a plus b minus t. So what do we have? A plus b minus t. Then dx, what is dx here? Minus dt. Can you see? Slowly we are coming to what we want to prove. Now we got that term. But now the thing is we have to match. Here it is A to B, but here it is B to A. Because the limit is getting exchanged. Now we know, that's what I gave you the properties. We know the property which I just quoted, that integral A to B f of x with respect to x is same as minus of integral B to A f of x dx. What we are trying to say here, here lower limit is A, upper limit is B, here lower limit is B, upper limit is A. When I'm going to exchange the lower limit to upper limit and upper limit to lower, when I'm going to exchange this, here the sign is plus, it will change to minus. If it is minus, see this, now here lower limit is B, upper limit is A. If I exchange this, the minus will change to plus. So then saying no, sign will change from positive to negative. I would like to say sign will change. It means plus will change to minus and minus will change to plus. Okay, so when I apply that, see this, if I change the limit, now if I t, okay, for just for your understanding sake, I wrote t. Now it is what? A to B f of A plus B minus t, and this minus will change to now plus. No, I don't have mentioned any sign. Actually, I'll write minus into, there's no sign here, plus. So minus into plus is minus. Then I should write this, it's understood. Now you see A to B, yes, it's matching. Now here we have x, but here we have t. Again we have one more property which I gave you. Integral A to B f of x with respect to x is same as integral A to B f of t with respect to t. So I can always change the variable identity type. Okay. So integral, this will become now integral A to B f of A plus B minus x with respect to x. Yes, we have got. And don't forget the left hand side. Where is left hand side? Yes, here. Just substitute it. Left hand side, integral A to B f of x with respect to x. Hence, we have proved the integral property, one of the integral property. Now comes problem. So this year you will get 3 to 4 marks. Now the have to complete the problem by using this property. Kindly make a note. Dear students, now let us move on to this problem to solve by using definite integral problem. So this is 6 here. So coming to solving this problem, evaluating this, let us consider what we have. Integral pi by 6 to pi by 3. 1 divided by 1 plus root of tan x with respect to x. Now see this limit, means this property, what is saying? This is saying that always you can replace x by lower limit a plus upper limit b minus the variable x. That's what you can see now here. So same thing I will apply here. Replace the variable x by lower limit pi by 6, upper limit pi by 3 minus the variable x. Simplify this. If I simplify here, only this part I want to simplify. 6 and 3 LCM is how much? 6. 6 by 6 is 1. 1 into pi is pi. 6 by 3 is 2. 2 into pi is 2 pi. Minus x. Now here, pi plus 2 pi is 3 pi by 6 minus x. 3 1s are 3 2s are. X is being changed to pi by 2 minus x. So I can replace replace x by pi by 2 minus x in equation number. Okay, so there we are use 1, 2, 3, 4. So I'll take as 5 because there should not be any confusion. No, so I is using 5. Means again 1 here. So 1 is the other equation. So I have taken 5. So replace this in 5. If I replace in 5, see carefully what happens. Integral, and it's also saying that property that if you also change like this, that x is replaced by lower limit plus upper limit minus variable x, then also the values are equal. Okay. Now see carefully here. Integral pi by 6 to pi by 3, 1 divided by 1 plus root of tan of, in place of x, pi by 2 minus x. Pi by 2 minus x, and here with respect to x. So integral pi by 6 to pi by 3, 1 divided by 1 plus root of tan of 90 minus x is cot x with respect to x. Now see carefully. In the question we have tan. We'll take as I here, okay? In the question we have what? Tan. And what we have got there? Cot. Tan and cot are reciprocal of each other. Let us try to simplify this. Can't we rewrite this one as pi by 6 to pi by 3, 1 divided by 1 plus root of tan, cot is same as 1 by tan. See the way I wrote the root. Entire is both numerator and denominator is covered. Now, if this is equal to pi by 6 to pi by 3. Root is taken for both, so I can split. See carefully. Root of 1 is 1 divided by root tan x with respect to x. There is nothing but 1. So here we have plus. LCM of 1 and root tan x is root tan x. So 1 dx here, denominator. Yeah, here. Root of 1 and root tan x is root tan x. What will be root tan x by 1? It will be root tan x multiplied to numerator. 1 into root tan x is root tan x. Plus root tan x and root tan x were cancelled. 1 into 1 is 1. So pi by 6 to pi by 3. Now this root tan x will go to numerator. So what we are going to get? We are going to have pi by 6 to pi by 3. Then root tan x into 1 is c. Root tan x into this one will be root tan x divided by this term as it is. Root tan x plus 1 with respect to x. Fine. Okay, let's again, I could have written next slide. Fine, right again. What is that? Pi by 6 to pi by 3, just for a clarity. Root of tan x divided by this one. See, I got 1 plus root tan x, and here we got root tan x plus 1. Is it not? A plus b is same as b plus a. So I can rewrite this one as what? 1 plus root tan x. This we will take as equation number 6. Don't forget, since it was I, throughout left hand is what? I only. So we got in terms of this. Now we are just going to add 5 and 6. First, kindly make a note. I'm going to erase this side. Kindly make a note. Yes, dear students, see carefully. Yeah, as we have taken this as what? Equation number 5, correct? No? Now see carefully. Now I'm going to just add 5 and 6. When I'm going to add 5 and 6 for all this property problem, the same thing. After applying, simplifying, we are going to add the given question and what we have got the resultant after applying the property. So I plus I, 2i. When we say add left with left, right with right, then integral of pi by 6 to pi by 3. Yeah, pi by 6 to pi by 3. Same. And since integrals are same, we can add only once. Okay. Now here we have 1 divided by 1 plus root tan x. Then plus. Here the integrand is root of tan x divided by 1 plus root tan x with respect to x. Now see carefully. Here we have a fraction. So I have to take LCM because plus sign is there. Denominator is same. LCM of a and a is a. So LCM of 1 plus root tan x and 1 plus root tan x will be 1 plus root tan x only. 1 plus root tan x by 1 plus root tan x is 1. 1 into 1 is 1. Then plus as it is. 1 plus root tan x by 1 plus root tan is what? 1. 1 into root tan x is what? Root tan x. Let us write the remaining term as it is. Pi by 6 to pi by 3. Now see carefully. This will get cancelled and get 1. So integration of 1 pi by 6 to pi by 3 1 dx. What is integration of 1? Recall. Oh, not, yeah, dx only. What is integration of 1 with respect to x? X plus c. So integration of 1 will be only x. Don't write c, as we have discussed that upper limit, lower limit will cancel c, right? So without writing the integral constant, we can just go ahead. So here it is pi by 6 to pi by 3. What is the upper limit? Pi by 3. So apply here. Pi by 3 minus lower limit pi by 6. LCM of 6 and 3 will be 6. 6 by 3 will be 2. 2 into pi is 2 pi minus 6 by 6 is 1. 1 into pi is pi. What is our left hand side? Don't forget 2i. So I write 2i back here. Now what is 2 pi minus pi? Pi by 6 is equal to 2i. Cross multiply 2. Erase this. Now I can erase this. Cross multiply 2. If we cross multiply 2, we are going to have I is equal to pi by 6 into 2 will be 12. But don't forget 6 into 2 is 12. Okay, but don't forget what is I. I is this, the given question. Therefore, integral of pi by 6 to pi by 3 dx divided by 1 plus root of tan x is pi by 12. Okay, so with this, our first model question paper problem, I will say model question paper number 3, first 6 marker done. Kindly make a note. Okay, dear students, now let us move on to the next property. Be careful, P0, P1, P2 are a property, correct? The other one which we have completed just before this was P3, then this is P4. So don't think that only we had the 3 properties. Since this has been asked in the model paper, I'm just continuing without listing out them. Okay. Now let us go ahead. That's what the argument heading, properties of definite integral. So we have to prove that integral 0 to a f of x with respect to x is same as integral 0 to a f of a minus x with respect to x, and then some problem is given to solve. Now see, if you just see carefully this, and whatever the property just now we completed, it was integral a to b f of x with respect to x is equal to integral a to b f of lower limit plus upper limit minus the variable with respect to x. Actually, this one is a particular case of this. In place of a we have 0, in place of b we have a. So if you just see, no, here what we did, replace x by what? Lower limit plus upper limit minus the variable. That's what you can see here. Similarly here, see, replace x by what? Lower limit 0, upper limit a minus variable. So what is x 0 plus a minus x? That's what we have got here. So this is a particular case of this. Okay, that's what I want to say. Now let us proceed with the problem, means the proof of this property. Okay, just for your extra information. Who knows, for 1 mark if they ask. Now see carefully, coming to the proof. We have been given this, so left hand side is integral 0 to a f of x with respect to x. Now again, same procedure what we just did for the previous property. We just saw that in place of this x we have got a minus x. So this is our equation number 1. So for the while, let I close the cap. Now what will you do? Replace the variable x. Oh wait, substitution will take substitution. Sorry, substitution. We are proving this result now. Okay. So in place of x, it is a minus x. So put what? A minus t. Same logic of the previous one. Equation number 2. Now differentiate this with respect to x. Derivative of x is what? 1. A is equal to 0 minus derivative of t with respect to x is dt by dx. Dx cross multiply 1 into dx is equal to dt with minus sign as it is. Now we have to change the limit as well. See carefully. Presently, what is the limit here? X, since dx is there with respect to x, x is equal to 0 to x is equal to a here. This is our equation number 1. This is our equation number 2. And here this is our equation number 3. Now what we are going to do? When we are going to find the new limit. So when x is equal to 0 in equation number 2, when x is equal to 0 in equation number 2, see carefully here, 0 is equal to a minus t, transpose here, we will get t is equal to a. Similarly, when x is equal to a, the upper limit, in equation number 2, that is here, we are going to have a is equal to a minus t. A and a, yes, got cancelled. So we are going to have from here t is equal to 0. This is our equation number 4. So now let us substitute. Put 2, 3 and 4 back in 1. So when we are going to do so, put equation number 2, 3 and 4 back in equation number 1. So equation number 1 will be integral of, when x is equal to 0, when x is equal to 0, t is a. When x is equal to a, the upper limit, when x is equal to a, the upper limit, t is what? 0. Next, f of x, okay. In place of this x, what do we have? A minus t. So substitute here, a minus t. Then dx, in place of dx, it is minus dt. So all we have substituted. Now again see what you want. It is 0 to a, but here it is a to 0. So again recalling the property that integral a to b f of x with respect to x is integral b to a f of x dx with minus sign. Whenever we extend the limit, lower limit to upper limit to lower limit, sign will change, plus to minus or minus to plus. So here when I'm going to do so, for this part, we are going to have integral a to 0 will change as 0 to a, then this negative will become positive, so only dt, and this is f of a minus t. Okay, now yeah, limit is same, but variable is x here. Again we have a property, recall what is integral of a to b f of x with respect to x, it is integral a to b f of t with respect to t. So I can change the variables, so it will be integral 0 to a f of, so in place of x it is t, so it will be a minus t, means to say a minus x. I can change from right to left it is, so I can change the variable t to x dx. Yeah, exactly matching. So the left hand side as it is 0 to a f of x with respect to x, and hence we have proved the result. Okay, I hope this is clear. Now let us take the sub problem. Kindly make a note of this. Fine. Now let us solve this problem evaluating this. So let us consider the integral. Consider, group part done. Now it is the solution for this problem. Consider the given question 0 to 4 root x divided by root x plus root of 4 minus x with respect to x. Now again we are going to use the property which says we can replace x by lower limit plus upper limit minus x limit a minus x. So here, since lower limit is 0, so I can just write replace x by 0 plus 4 is 4 minus x, and this will take as equation number or expression number 5, and again I will take as I. Now this is an equation. Okay. Now see carefully. If I do so, in 5, we are not substituting, we are applying the property due to which limit will not change. Okay. When we substitute, only then limit will change. So I is equal to 0 to 4. Wherever x is there, replace by 4 minus x. So in place of x, it is 4 minus x. Again, in place of x, it is 4 minus x plus root of 4 minus. Again, in place of this x, only in place of this x, what I'm going to have 4 minus x. Now see, error done by the student. They are not going to give a bracket here. They're just going to write. So now x will be minus x. No, it is not so. See, this minus is for this x multiple. So in place of x, you are writing the 4 minus x, this expression. No. So surely in place of x, when you are writing 4 minus x, this in place of this x, you have written this. Correct? No. So this minus should multiply the entire term. Okay. So basics are very important. Now see carefully. What we are going to have, integral 0 to 4 root of 4 minus x divided by root of 4 minus x plus root of, simplify this, what we are going to have, 4 minus plus is minus 4, minus minus is plus x. If you could have not given the bracket, you could have taken as minus x, gone guess. Correct? No? X. So let's write it here. Now one thing I want you to understand here, just a basic common sense. When you are replacing x by 4 minus x, it also means that wherever 4 minus x is there, replace by x. So in place of 4 minus x, directly I could write x itself in place of simplifying like this. Both are same. Now I will take this as equation number 6, and the left hand side is I. So now I'm going to add. As soon as the property is applied, now just add. If we are going to add equation number 5 and 6, I plus I is 2I is equal to integral 0 to 4. Okay, 0 to 4. Now since for this and this limits are same, there is no need to write what twice. Only one time integral is enough. So here it is root x divided by root x plus root of 4 minus x. Okay, this is done. Then coming this plus root of 4 minus x divided by root of 4 minus x plus root x. Okay, now see this carefully. The denominators are same. This is a plus b, this is b plus a. A plus b and b plus a are same. I can take LCM. LCM of this will be what? Root of x plus root of 4 minus x. So this by this will be 1. 1 into root x is root x. Then plus this by this will be 1. 1 into root of 4 minus x will be 4 minus x with respect to x, 0 to 4. Now very easily this will get cancelled. I'll get 1. Integration of 1. What is integration of 1 with respect to x? Recall, it is x. So apply the limit 0 to 4. So it is upper limit. Wherever x is there, upper limit minus lower limit. 4 minus 0 is 4. Left hand side is 2i. 2 ones are 2 twos are. So I is equal to 2. But what is I? What is I? This integral 0 to 4 root x divided by root x plus root of 4 minus x with respect to x is 2. This is the solution. I hope this is clear. Okay. With this 6 marker is also completed. Kindly make a note of this. Dear students, having understood the two properties of definite integral, now time for the last property, but that deals with one additional concept known as odd and even function. So before taking the properties, the last property from the model question paper, let us try to understand what is this even and odd function in detail. So I have written the heading as it is. For this property, we need one concept, as I said, even and odd function. Now let us try to understand the definition of even function. When do we say a function is even function? A function y equal to f of x is said to be an even function if f of minus x is plus f of x. Try to understand this. See this last line carefully and understand. Here we are commenting that f of minus x should be equal to plus of f of x. See, this is the function given to you, which is y equal to f of x. So if I replace this x by minus x, on simplification, we should get plus f of x. Only then we say it is which function? Even function. Now let us understand with the help of example. If I take example number 1, y equal to cosine function, cos x. Now I will take this as equation number 1. So in place of f of x, we have got cos x. Let us do one thing. To be still more specific, to be nothing wrong here, but to be still more specific, I will write y is equal to f of x is equal to cos x. Okay, na? So I have taken the function to be cos x. Now I am saying replace x by minus x. And this is our equation number 1. So in equation number 1, we are replacing x by minus x. If we do so, what we are going to have? So y is equal to nothing but f of, in place of it is minus x cos of minus x. Now recall, we know that from trigonometric function cos of minus theta is plus cos theta. So cos of minus x is plus cos x. Then plus as it is. In place of this cos x, we have what? F of x. And see carefully, here we had f of minus x. So you can see that f of minus x is what? Plus f of x. And we got this from equation number 1. In equation number 1, cos x is f of x. Therefore, I can say that f of x is equal to cos x is an even function. I hope you get clear. Now, let us also try to list out some examples of even function. So, some more examples of even functions are secant x, even function we are talking about. So, all the even power, if I take x power 2n, where n is any integer. So always you are going to have even, because you can see since power is even, always negative base whatever is there, but because power is even, it will be converted to positive. Next, which could be the other function? Yeah, only mod x. Only mod x. If I have got mod of some x plus 1, x minus 1, then it is not so. So I can replace x by minus x, will get mod x back. So it is an even function. So these are some examples for which function? Even function. Now let us try to understand when do we say a function is what? Odd function. So second definition, this is the first definition. Now coming to second definition, odd function. What is this odd function? A function y equal to f of x is said to be an odd function if f of minus x is equal to minus f of x. So if I replace this x by minus x, I should get negative out. Only then we say it is what? Odd function. Okay. Now, having this, let us try to take an example. For example, in trigonometry itself, if I take y is equal to f of x is equal to sin x. Now, if I replace what? X by minus x in equation number 1. This is our equation number 1. If we replace x by minus x in equation number 1, we are going to have f of minus x y is equal to sine of minus x. Recall what is sine of minus theta? It is minus sine theta. Sine of minus x is minus sine x is equal to minus as it is. What is this sine x? Only this sine x. This is what? F of x. So f of x as it is. And here we have f of minus x. So f of minus x is minus of f of x we have got. Therefore, we can comment f of x is equal to sine x is an odd function. Is an odd function. Now, do we have some more examples for odd function? Yes, do we have examples of odd functions. Okay, examples of odd functions. Okay, are coming to this, it can be coming to trigonometry. Cosecant x, don't forget cosecant of minus theta is minus cosecant theta, then tan x, cot x. So coming to trigonometric function, there are only two trigonometric functions, secant and cos to be even function, whereas the remaining four trigonometric functions, sine, cosecant, secant and cot are what? odd function. Coming to inverse trigonometric function also, don't forget sine inverse of minus x is minus sine inverse x. So sine inverse x, then cosecant inverse x, and tan inverse x. If I give negative, it will be, the negative will come out there. Okay. Whereas cos inverse, I mean say cos inverse, secant inverse, and cot inverse are neither even nor odd. Let I do one thing. Let I give you the reason. You know how you see. Okay. Let I do one thing. As a note, I will give for all the trigonometric function negative and ITF also negative value. What is the answer, so that you will have a better understanding. Having this coming to polynomials, all the odd power. But again, n is an integer, will be what odd function, because when you replace x by minus x, since base is negative but power is odd, is also an odd function. I mean to say, whenever we have odd power. For example, if I take y is equal to, suppose no, f of x is equal to some odd power, x power 7. Okay, so if I replace x by minus x in this equation number 1. See carefully, wherever x is there, replaced by minus x. So we are going to have f of minus x, correct? Now is equal to x power minus x power 7. That's what we did here, correct? So now since power is odd, negative will come out. But don't forget, what is this x power 7? It is f of x. So f of x as it is. So what we have got, f of minus x is minus of f of x. So it's very clear that whenever you have got odd polynomial, means the power of the polynomial to be odd. I mean to say power of the polynomial is odd. So degree is odd. The highest degree is odd here. Is which function? Odd function. That we can also see for this also. I hope now you can generalize that if I have got even power here, for example 4, then minus x power 4 will be plus, so it will be an even function. That's what we have commented here. Now let us try to give a note for you here. What about the different negative value for all the trigonometric function and ITF, so that you understand and relate here. Okay, now see this carefully. We know that I think space is insufficient, so I will just clear only this part only. Okay, only this part I will clear. Kindly make a note. Or better, I'll clear this side. Let I clear this side. Let it be continuous from there to here. See carefully. I just want you to know this all properties. See carefully. As a note, we can have what is sine of minus x? It is minus sine x. Second, tan of minus x is minus tan x. Third one, cosecant of minus x is minus cosecant x. Fourth one, cot of minus x is minus cot x. So because of this reason itself, sine, tan, cosecant and cot, since it obeys this condition, this is what this is all about odd functions. That's what I have commented here. Sine already is there here. Cosecant, tan and cot are odd functions. Coming to inverse trigonometric function, let us take that also. Sine inverse of minus x is minus sine inverse x. And this is happening for each and every element of the given domain for all x belongs to R. So you can also write here that this is true. This should happen for all x belong to domain of f. That is obvious. Okay, domain of f. DOM stands for domain of the function f. Same for even also. Now here, 6th point, cosecant inverse of minus x is minus cosecant inverse x. Then 7th one is tan inverse of minus x is minus tan inverse x in the domain, defined domain. So this is all the example for what odd function. So whereas coming to this 8th one, let us suppose I take cos of minus x, it is plus cos x, whereas secant of minus x is plus secant x. Okay, so this will be the from here to here. It is odd function, whereas this two is what? Even function. Now the question mark is, what about the remaining ITF? We have discussed 1, 2, 3, 4, 5, 6 trigonometric function, but coming to ITF, inverse trigonometric function, sine inverse, cosecant inverse, and tan inverse. What about the remaining? So for that, let I just give the formula first. What is cos inverse of minus x? It is minus cos inverse x. No. It is pi minus cos inverse x. Okay, this property actually is due to reduction of the syllabus. This property result was being not given, but it is let us have this knowledge. Then what about secant inverse of minus x? It is pi minus secant inverse x. And lastly, what about cot inverse of minus x? It is pi minus cot inverse x. Okay, so I think I've given all the information. Now let us try to go ahead. So this note, whatever I wanted to give, I have just mentioned here. So now let us try to understand one more thing, whether every function whichever is given is always even or odd, or can we have a function which is neither even nor odd? That is the next question. Okay, first kindly make a note of this. Okay, now dear students, let us move on to, as I said, whether every function is even odd. For that, let us take one example here. F of x is equal to cos inverse of x. Now to check whether it is odd or even, one thing is sure, replace x by minus x. Correct? Now for odd function, recall, for odd function, f of minus x should be minus f of x, and for even function, f of minus x is plus f of x. Okay, so now here if you see, if I take again this is equation number 1, so replace x by minus x. If I do so, this will become y is equal to f of minus x is equal to cos inverse of minus x. Now since we know that cos inverse of minus x is pi minus cos inverse x, so we can just write it here. And now you see carefully, this is nowhere same as equation number 1. This is nowhere same as equation number 1. So it's not equal to, nor it is equal to plus f of x, nor it is equal to minus f of x. So f of minus x is neither equal to plus f of x nor minus f of x. Therefore, f of x is equal to cos inverse of x is neither even nor odd function. So we have some example where it can be neither even nor odd, and here from this you can really clearly say some more examples. Examples of, see this one we call now neither even nor odd. So in short we will be calling like this. See this carefully. Neither, n, first letter of the word neither, then even, so e, and then nor, no, n, so again n, then odd, o, so again I can write o here, nano, neither even nor odd. So examples of nano function in our class I will call nano function, neither even nor odd, are, first you can see here, from here it is secant inverse and cot inverse. Similarly, exponential function a power x also. If you replace x by minus x, we'll never get it. Let's take one example here. Let us try to understand why this is nano function. So if I take example number 2, y is equal to f of x is equal to a power x, equation number 1. So if I replace x by minus x, f of minus x is equal to a power minus x. I want power of a to be positive, so I can only bring this one down. Then what I got, 1 divided by f of x is a power x is f of x. See what has happened. This I got as this. So f of minus x, the left hand side, is equal to 1 by f of x. This is nowhere equal to f of x. I'll get this as f of x whole power minus 1. But here f of x power is 1. Therefore, this is the reason why it is what nano function. Okay, a is any positive real number. As you know from the concept, a is positive and a is never be equal to 1 and x is any real number. Okay, in their respective domain. So I hope these things are clear. Now, one thing is, what about constant function? We have discussed exponential function. What about the constant function? Which type of function is that? Is it even or odd? Let us have the discussion. First, kindly make a note of this. Okay, now our discussion is about constant function. What do we think? A constant function is even function or odd function? Okay, so now the discussion is discussion on constant function, on a constant function, whether it is even or odd. Okay, so for this, let us proceed with the problem, means concept. So let us see y equal to f of x if I take any real number c, where c is any real number. Okay, constant function. Now just see carefully. This we will take as equation number 1. Now here, let us replace. See, to check whether it is even or odd, we have to replace x by minus x. So if I replace x by minus x in equation number 1, we are going to have y is equal to f of minus x. Wherever x is there, replaced by what? Minus x. Understand this. Wherever x is there, replaced by minus x. Do we have x here? No. So c will remain c. So actually what I got? C. What is c? What is c? So equation number 1, f of x. And what is our left hand side? F of minus x. So what we got here? F of minus x is plus f of x. So this implies f of x is equal to c is even function. Mean to say every constant function is even function. I know many students now will be having a doubt. Sir, c is there, some plus is there. Can you give some particular number? So for that reason, because of this, now I'll take 2 examples here. Okay, example number 1, E, G stand for example. Let us take one constant, positive constant. Let's suppose 7. Now, here we have proved in general that every constant function is even function. Now the thing is, what can we say about this? So for that, I'm taking this as equation number 1. So replace x by minus x. So now wherever x is there, replace by minus x. So see carefully. Now when I'm going to replace, f of minus x is there, correct? So here wherever x is there, replace by minus x. Do we have x? No. So 7 will remain 7. But what is 7? F of x plus f of x, that too. There is no sign here, no, it means what? Plus. So plus f of x. And here left hand side as it is. Can you see? F of minus x is equal to plus f of x. Therefore 7, this implies f of x is equal to 7 is even function. Which function? Even function. But still student will have a doubt. Sir, if you take negative, surely it will be odd function and this comment will be wrong, sir. Let us take it out. I'll take the same number 7 but with minus sign. F of x is equal to minus 7. So now this again I'll take as equation number 1. Since I have taken as a subproblem 2, so surely now equation number can be same. Now if I just see again, replace what by what? X by minus x in equation number 1. So here y is equal to f of minus x. We are saying very clearly, replace x by minus x. Do we have x here? No. So minus 7 will remain minus 7. Okay. So we are going to have minus 7, nothing but f of x. And here it is f of minus x. See here, minus 7 is f of x. Yeah, minus 7 is f of x. So what we got? We got it to be what? Even function. So this implies f of x is equal to minus 7 is even function. So whether it is negative or positive, it is always negative function. That's what I comment here. Every constant function I can say now is even function. Okay, see any real number. It can be positive, negative, or zero also. Kindly make it. Yes, dear students, let us move on to the last property, 6-marker question. We do also have 1-marker question. That is on even and odd concept. Let us complete this and then we will take over that. Now coming to this property, it says prove that integral minus a to a f of x with respect to x is 2 times of 0 to a f of x if f of x is even, 0 if f of x is odd. See, I would prefer you to remember the definition also. Who knows in examination than saying f of x is even, they may say f of minus x is f of x itself. In place of giving f of x even, they might give the definition. And here also, in place of saying f of x is odd, they may say f of minus x is minus f of x. Okay, now let's move on to the proof. Coming to the proof of this, see the left hand side. The left hand side is integral minus a to a f of x with respect to x. We do have some problem. First, let us concentrate on proving the this property. Now see carefully, see what we want. It is starting from 0 to a. Okay, between minus a to a, I have here a here. So if I plot a number line between minus a to plus a, 0 will be the midpoint. So I have to break the integral to 0. That's the reason I gave you all the properties. We also know that integral a to b f of x with respect to x is integral a to c f of x with respect to x plus integral c to b f of x with respect to x. Okay, so I can break c can be, now c is the point between a and b, it can be out also. Okay, now just see this carefully. Now 0 is lying between minus a to a, so I can break this integral at 0. So minus a to 0 f of x with respect to x plus integral 0 to a f of x dx. So with respect to x, I mean to say here, so minus a to 0 and 0 to a. Now see carefully, this is matching with this. We have a problem with this. Okay, now so let us write this term. Now in this, my only focus part is, oh, both are black. Oh. Yes, here it is. Now my only focus part is this, and I recall as 1. I'm not touching this part. It's matching with what I want, but I am not happy with the lower limit. It is minus a to 0, but I want 0 to a. So let us consider that separately and try to simplify. Consider the integral minus a to 0 f of x with respect to x. Now you see carefully, in place of x is minus x, let it be even or odd. So let us take this as equation number 2. This is a minded. So this is equation number 2. So this is expression number 2. Now since here we have a, but whereas we have got minus a, I have to take such a substitution that negative can be converted to positive. Don't forget from school this, if at all you have got negative, how to make it positive? It is actually minus into minus will be plus. So I will take one negative substitution, put the variable x as some minus t, expression number 3. So now you differentiate this with respect to x. Derivative of x is 1 is equal to minus dt with respect to x. We can cross multiply. Dx is equal to minus dt. This is our equation number 3. Now let us put it back, but before we put, don't forget, since we have got with respect to x here, these are x value, x is equal to minus a to x is equal to 0. So I have to go for change of limit, nothing but I should get the new limit for the new variable t, and I have to surely go for that step where you have a substitution. So put x is equal to, in place of x, lower limit minus a, in equation number 3. This implies in place of x we have minus a is equal to minus t. Negative will get cancelled. From here what will get? T is equal to a. Next, if I put or when x is equal to, okay, both are same. Then saying I think put now is better to use the word when. Okay, when x is equal to, this is ideal. X is equal to what? X is equal to 0. In equation number 3, here we have x to be 0 is equal to minus t, or I can say t is equal to, whether it's 0, see, if I take minus here, whether it's minus 0 or plus 0, both are one and the same. This is our equation number 4. Now I just put all this thing, wait, 3 here, no, this is 4, yes, and this is 5, okay. So put equation number 3, 4 and 5 back in equation number 2. What will be equation number 2? First, let us write the equation number 2. The expression number 2 I mean to say, integral minus a to 0, f of x with respect to x is equal to, see carefully, integral, in place of f of x, in place of this x, what do we have? Minus t. Then in place of dx, we have minus dt. So just we are going for one by one substitution there. Then when x is equal to minus a, when x is equal to minus a, what is the value of t? Plus a. So plus a. When x is equal to 0, what is t value? 0. Okay. Now match up what you wanted. You actually want 0 to a. But you see, you got a to 0. Fine. And now you see, here we have negative. If you just compare, here you have got 0 to a, but here you have got a to 0. We know one property that integral a to b, f of x with respect to x is same as minus of integral b to a, f of x with respect to x. Nothing but when I exchange the upper limit to lower limit and lower limit to upper limit, the sign will change. The sign will change from positive to negative and negative to positive. Okay. So here, if I rewrite this one as 0 to a, then f of minus t, and this minus dt will become a plus dt. I hope this point is clear. Now you see 0 to a, it is matching to 0 to a, but we want it to be x. But here we have got I mean to say t. So now I have to erase. To do one thing, I will retain this part, this side as it is. Okay, because I want to use this. So I'll be erasing this part. First, make a note of this. I'm going to erase this side. I'll erase without stopping the video, so you understand that I am just continuing from here. This part will not be required for me. So I am erasing this side. Surely you have to copy down this. You have to make a note of this, and don't forget this left hand side was what? The left hand side of this was integral minus a to 0 f of x with respect to x. Don't forget that. We know that integral a to b f of x with respect to x is integral a to b f of t with respect to t. We can always take the variable. So I can go from right to left as well. So in place of t, can we have x? So we'll have integral 0 to a f of minus x with respect to x. And left hand side is what? Integral minus a to 0 f of x with respect to x. This we will regard as equation number 6. And now let us substitute 6 in 1. So put equation number 6 in 1. Then our equation number 1, left hand side is what? Integral minus a to a f of x with respect to x is equal to minus a to 0. I repeat, I wrote this one as it is now. Now here, minus a to 0 f of x with respect to x is here, which is integral 0 to a f of minus x. Okay, and this term as it is. Now since the limit 0 to a here also and 0 to a here also, we can avoid writing what? Integral twice. So I can only write f of x with respect to x. Now from here, we have to apply the condition. We have not applied this condition. Okay. Now let us go for the condition one by one. See carefully. Pay attention. This is our equation number 7. Now we will apply the condition. What? If f of x is even. See, if f of x is even. So case 1. If f of x is even, that is f of minus x is plus f of x. If I put in equation number 7, then what will be equation number 7? Integral, let us erase this. See carefully. Integral minus a to a f of x with respect to x is integral 0 to a f of minus x. In place of f of minus x, what do we have? Plus f of x. Let us substitute here. Plus f of x. Then here we have plus f of x here as it is, no change. So what is a plus a? 2a. So f of x plus f of x will be 2 times of f of x. So 2 I will take out. 2 times of integral 0 to a f of x. Again I repeat. What is f of x plus f of x? 2 times of f of x. So 2 of integral 0 to a f of x with respect to x. That's what they wanted. You can see here. And left hand side as it is. Okay. I hope this point is clear. This part is done. Now let us move on to the next. If f of x is odd, so again we are going to substitute here only. If f of x is odd, when we say odd, what's the meaning of this? F of minus x is minus f of x. If we substitute in equation number 7, then we are going to have again here integral minus a2 plus a f of x with respect to x is equal to, in place of this f of minus x, what we should have? Minus f of x. I repeat, in place of f of minus x, we should have minus f of x because f of x is odd function. So integral 0 to a as it is, and this will be f of x with minus sign, and then plus f of x as it is with respect to x. Now see carefully, minus f of x and plus f of x will get cancelled. We are going to have 0. Let us erase this. Now it's not required for us. It's not difficult but bit lengthy. See carefully now. Now what is remaining? What is remaining from here? Continuation. What do we have? We have integral minus a2 plus a f of x with respect to x is equal to integral 0 to a. This value on subtraction we have got only 0. What is definite integral of 0? We have already learned it is 0 only. As a list of formula, I gave you the reason as well how it is 0. So integral minus a to a with respect to f, means integral minus a to a f of x with respect to x is what? 0. That's what they wanted. So combining those two, so I can say this is our equation number 8. Okay, and this is our equation number 9. Combining both of this, what you get? Therefore, integral minus a to plus a f of x with respect to x is equal to, two things can be done. One is here, 2 times of 0 to a f of x with respect to x if f of minus x is plus f of x, whereas 0 if f of minus x is minus f of x, nothing but odd function. For even function, for even function we got 2 times of this, that's what we have. And for odd function, as you can see here, for odd function what we got? 0. And this is our case number 2. Okay, mind it, this is our case number 2. Okay, fine. So with this, proof is done. Now we'll take the problem. Kindly make a note. Okay, dear students, now problem, let us consider. Now see carefully the benefit of properties. No, so you can integrate this one, okay, usual way also, but tan power 5 is very lengthy, and here you have to apply by parts. So you can just see the benefit of what properties which we have learned. Okay, now I have to evaluate. So now I'm going to evaluate integral minus pi by 2 to plus pi by 2 x cube plus x cos x plus tan power 5 x with respect to x. Now let us consider this integrand, and since we can see lower limit minus pi by 2 plus upper limit plus pi by 2, how to know? I have to use even and odd constant property, this property of definite integral. As you can see, lower limit negative, upper limit positive. Whenever lower limit is negative, upper limit is positive, only then you will think about even or odd function. If it is even, then it will be 2 times of 0 to a, odd directly 0. Now let's check whether it is even or odd. So f of x, the integrand, in place of this f of x, we have got this entire expression. Let's write here x cube plus x into cos x plus tan power 5x. Now I have to check whether it is even or odd. So what we can do, replace x by minus x in equation number, I really don't remember. So I'll do one thing. Equation here, Naseer Ahmed. So replace x by minus n in equation number n. So we are going to have f of minus x is equal to minus x cube, then plus of, in place of x, minus x. Again here cos of minus x. Then next line plus tan. Can't write as tan of minus x, and don't forget, actually this is what, tan x the whole power 5. The whole power 5. Okay. So now since power is odd, negative will be out. So minus x cube plus into minus x, cos of minus x is plus cos x. Then what is tan of minus x? Minus tan x whole power 5. Reason, let us write down, cos of minus x is plus cos x. So you can see minus plus is minus x here. Cos of minus x is plus cos x. That plus into this minus what? Minus only. And what is tan of minus x, which is minus tan x. So here, see carefully, minus x cube, then minus x into cos x, power is odd, so minus will be out now because power is odd, base negative. So minus into this plus will be minus. I repeat, minus will be out because power is odd. Then that minus into this plus will be minus tan x power 5 I can write. Now you see carefully what is common here in sign negative. So minus of minus plus x cube, minus plus x into cos x, minus to minus will be plus tan power 5x. Now what is this entire thing? This entire thing is nothing but, present here nothing but f of x. So minus as it is, and then we have got this as f of x. Don't forget the left hand side, it is f of minus x. And this is the definition of which function? Odd function. That is f of x is equal to whatever the expression they have given, that is x cube plus x into cos x plus tan power 5x is which function? Odd function. Since it's an odd function, come to the theorem, means property. If it is odd function, that is what? 0. So this entire value is what? 0, as it is odd function. Now be careful, this should be shown in the working. This will give you some 2 marks and along with this. So directly you cannot comment it is 0. You have to give the reason why it is 0. It is 0 because it is odd function. Okay. Kindly make a note. And now I will be giving a short trick also. If it is coming for 1 marker, how are you going to deal? There is no need to go for such a lengthy process for checking odd function, even function. But yes, for this problem, for 6 marker, along with the property, you have to go with this procedure only, and mind it, this is the end. Okay. Okay, fine. Now looks better. Kindly make a note. Okay, dear students, now let us try to have a short trick for even and odd function. See, actually we say short trick, but it's actually concept again. See, recall for odd function. For odd function, what is the definition? Definition is, if I replace x by minus x, I should get back what? Minus f of x. So whenever I am talking about odd function, sign is what? Negative. If I talk about even function, f of minus x is plus f of x. Nothing but whenever I'm going to replace x by minus x, my sign should be what? Plus. So whenever I get plus, it is what? Even function. So for first, understand this. For odd function, I will take negative, and for even function, I will take a positive. As soon as I come to know which type of function is that. Now, I will take the same problem. See carefully. F of x is equal to x cube plus x into cos x plus tan of x whole power 5. Now coming to odd and even, see how we are going to go about. And for this, the concept which I gave you, that will be very important for going ahead. Now see carefully. X cube is which function? Odd function. So minus. X power odd, I said odd function. Next, x, this x is which function? X power 1, odd power. So power is odd, so it is odd function. Here it is x into cos x. So it's a product of two terms. Cos x is which function? Even function. So plus, because it is even function. Tan is which function? Odd. So minus. Now here you see carefully. This is odd, but here we have a product of odd and even, but here it is a multiplication. So very simple. What is minus into minus? Plus. Plus into minus, minus. Minus into plus, minus. Plus into plus, plus. So product of even and odd is odd. Product of odd and even is odd. As I said, wherever I have got minus, I will be taking as odd function. For even, take plus function. So minus to minus plus. So product of two odd will be even. Product of two even function will be, I repeat, product of two even function will be again even function. Now you see carefully. Minus to plus is what? Minus. So this is odd. This also odd. This also odd. So the entire function is what? Odd function. F of x is odd. Since f of x function means, I mean to say, f of x is odd function, therefore integral minus pi by 2 to plus pi by 2 f of x, nothing but this entire function with respect to x is what? 0. So what is so much? Just in one line we got, but for that I should know what is each function type. Nothing but concept it is. Correct? Along with the trick. Fine. Kindly make a note. Dear students, now we are with the last problem from this chapter, integrals under definite integrals. This is from model question paper number 1, a 1 marker question. They are saying find the value of. Now here we are not going to do the usual procedure. Recalling that for odd function it is minus 1 and for even function plus 1, that's also there. But I have also given whenever power of x, any polynomial you have got, and if the power is odd, there is an odd function. So since and how to know, I have to use even and odd concept for definite integral problem. I said you lower limit, upper limit should be same, and sign should be opposite. You can see signs are opposite. Here it is minus 1 and here it is plus 1. Correct? Due to which I can go with odd and even function. So since power of x is what? Odd, 99. So this is entire function what? Odd function. And we know that for odd function, the definite integral value from minus a to plus a. From minus a to plus a, f of x with respect to x is 0, provided f of x is odd function. F of x is which function? Odd function. Therefore, the value is 0 because odd function. Option C is correct. Okay. Now here there are two properties which I've just listed out, so that let all the properties you are aware of. Okay, fine. So with this we come to an end on integrals chapter. Both definite, I mean to say both indefinite and definite integrals together we have completed. Part 1, part 2 are on indefinite integral, and this part 3 is on definite integral. Shortly we'll come with differential equations. As you know, application of integrals long back it is uploaded. Kindly make sure go through all to have a better base or the firm knowledge. Okay, so make sure study well, give you 100%, be dedicated, hard work, exam is just approaching. Okay, and study. God bless you all. And also do like, share and subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you all.